From the previous lecture series, we are continuing the lecture series in the course Production Technology. Last class, we have seen what are the common welding types. Here we can see what is the procedure to weld steels. So welding of steels is our today's topic. This presentation will explore the fundamental principles of welding steel, focusing on common process, joint designs, and quality assurance. So what is steel welding? A process that joins two or more pieces of steel by melting and fusing the metal at the joint, creating a strong and durable bond. As we discussed, it's a permanent joint, and most of the applications we use steel as one of the primary raw material, since it has many uh, adorable properties like joint strength and tensile strength, hardness, and it has a good microstructure after weld. And the importance of steel welding crucial in various industries, including construction, manufacturing, and infrastructure, used to build bridges, vehicles, and more. So steel welding, commonly we use three types of welding. One is arc welding, using an electric arc to melt the metal. Common types include shielded metal arc welding and gas metal arc welding. Gas welding uses a flame from a mixture of fuel gas and oxygen to melt the metal. Common types include oxy-acetylene welding and oxy-fuel welding. And laser welding, we use a high-power laser beam to melt the metal, offers a precision and minimal heat input, ideal for delicate applications. So laser welding is not only used for joining two pieces, it is also used for cutting profiles, and we use various applications for profile cutting. So normally the factors affecting steel weldability is chemical composition, number two, microstructure, thickness, and temperature. Let us see one by one. The amount of carbon, manganese, silicon, and other alloying elements present in the steel affects its weldability. The arrangement of grains and phases within the steel affects its weldability. Fine-grained steels tend to be more weldable. The fusing of atoms becomes very much easier and the bond breaks easier when there are fine-grained steels. Thicker steels require high heat input and different welding techniques than thinner steel. Finally, the temperature. The temperature of the steel being welded can impact its properties. Preheating may be necessary for thicker or high-strength steels. So we all know basic joints, butt joint, lap joint, uh, fillet joint, and corner joint are the four basic joints that is also applicable to steel. Proper preparation and cleaning of surfaces. So surface cleaning, edge preparation, preheating are the three major things we have to take care while preparing for a welding process. Surface cleaning removes contaminants such as rust oil, grease, essential for strong and durable weld. Edge preparation prepares the edges of the steel to be joined. For proper fit up and penetration of the weld, preheating may be required for thicker steels and to prevent cracking and ensure proper welding. So normally any welding process will lead to some challenges like defects, residual stress, distortion, safety, all these things to be looked into. So best practices and quality assurance in steel welding is proper training ensures welder have the necessary skills and knowledge to perform high quality welds. Quality control procedures, including visual inspection, X-ray testing, and other methods to ensure weld quality. Use of certified materials ensures the steel being welded meets industry standards for strength and durability. Regular maintenance of welding equipment helps ensure that welding equipment is operating correctly, producing high quality welds. I hope you understood about the welding of steels. We'll meet you in the next lecture series.